Hi, in this video, we're going to do some OSPFv2 basic configuration. Okay, so it all starts off with the router OSPF10 command. Okay, and the 10, that's just a process ID. So router OSPF and a process ID, which can be anything between 1 and 65,535, just chosen by the network administrator. It's locally significant, so it doesn't have to match other OSPF routers. Remember, that differs than EIGRP, where they must match the process ID, or they call it autonomous system number, must match for routers to become adjacent. But in OSPF, it's they just locally significant. Doesn't have to match, but it's best practice to have them match. Okay, so the OSPF router ID, how is that established? Okay, it's used with it's the IPv4 address configured with the OSPF router ID command. We'll see that in a moment. If that's not configured, it's the highest IPv4 address of any of its loopback interfaces. If it has no loopback interfaces with an IPv4 address, then it's the highest active IPv4 address on any of its physical interfaces, whether or not it's a OSPF v2 interface or not. And again, we say IPv4 address. That's how we designate it. It's really just a 32-bit value. Okay, so how do we define the router ID? We just say router ID and the IPv4 address. Again, an arbitrary 32-bit value written in dotted decimal. Okay, and it'll take place after the router reloads, or if you clear the IP OSPF process. And then that restarts the OSPF process with the new router ID. Okay. So here's an example defining the router ID on router R1. Pretty straightforward, just the router ID command. And because it is a 32-bit value, by the way, that's the same as in OSPFv3, so OSPF for IPv6. So they both require a 32-bit router ID. All right. So here I do show IP protocols, and we can see the router ID listed there. Changing the OSPF router ID. So if I change the OSPF router ID, this version of iOS actually tells me to clear the IP OSPF process command for it to take effect. So I do that. It says, are you sure you want to reset all my OSPF processes? That means adjacencies. It's going to reset all the adjacencies. We got to go through forming new neighbor adjacencies, all those OSPF states to full state, rerunning the SPF algorithm, et cetera, et cetera, et cetera. Okay. Then finally, we do show IP protocols when it reaches full state, and we can see the new router ID. So here I just did show IP protocols, pipe, section, router ID. So that means show me any line that has the word router ID in it, or the section that has router ID, excuse me. Okay, you could also alternatively configure a loopback address, but really, loopback addresses are used for a few things, but, in lab purposes, we can use them for just creating interfaces where we don't have physical interfaces and we want to do some testing. But it's always best to use the router ID command for the OSPF router ID. All right, so how do we enable our interfaces, advertise our networks in the LSAs via OSPF? We do that similar to other routing protocols or other interior gateway routing protocols. We use the network command. So the network command, what it does, we say network, the network address wildcard mask. We'll talk about wildcard mask in a moment. Area, and then area ID. In single area OSPF, we usually use area 0 for our area ID. We'll talk more about area IDs in multi-area OSPF. But the network address and wildcard mask. So when we use a network command and we specify an interface, one of our interfaces, and we give the network address of that interface and its wildcard mask, which is just the inverse of the subnet mask, what this tells iOS and OSPF is that any interfaces on this router that match this network address will be enabled to send and receive OSPF packets. Also, very important, this network, or the subnet thereof of that interface, will be included in OSPF routing updates in the link state advertisement saying, I am directly connected to this link, to this network. All right, so it requires a wildcard mask, which we're going to take a look at. So wildcard mask is just the inverse of the subnet mask. So we take quad 255, subtract our subnet mask of that interface, and we get the wildcard mask. Like EIGRP, some iOS versions will actually let you use the subnet mask in the network statement, but when you look at it in the running and startup configs, you will actually see the wildcard mask. It actually converts it from the subnet mask to a wildcard mask. Okay, so the area ID, I mentioned this all before, but we'll talk more about this when we get to multi-area OSPF. In single area OSPF, we're pretty much just going to, you need to use the same area ID for all your routers in single area OSPF. It's best to use area 0, which is best practice. Okay, so let's go ahead and look at some configurations. So here on router R1, okay, we've got the router ID. We have our process ID of 10. Okay, we're going to network 172.16.1.0. So that will advertise the gig 00 interface right here. The 172.16.3.0 interface, that will advertise, enable the serial 000 interface. So we've got 2 interfaces enabled. And this last network statement will enable the serial 001 interface. Again, does 2 things. It allows that interface to send and receive OSPF messages or OSPF packets to form adjacencies on those networks. It also will advertise these networks in the link state updates flooded in the OSPF area. Okay, here's an optional method of doing this. Is actually you can instead of the network command, you can identify the OSPF network on the interface itself. So you just go to the specific interface, say IP OSPF, the process ID 10 area 0. And we can do that for all, there we go. We can do that for all the interfaces. You know, however you do it, it's best to be consistent. Make your life easier. Be consistent on that router, be consistent in your network. Okay, we'll be doing more on OSPF configuration in the following videos.